Hi everyone, in this video tutorial we will use composite material for strengthening our concrete specimen in 3-point bending test. In this video we will use the composite material to add more strength in our concrete specimen, and we will see the effect of our composite in our strength by getting the maximum force displacement force reached by after strengthening our specimen. Let's get started. Let's start with creating of our CFRP sheet for strengthening our specimen concrete. Create part, CFRP sheet, composite sheet. Let 3D dimension deformable shell planar. Click continue, and let's sketch our parts with length of equal to 250 millimeter and 150 millimeter in width. Now we have our sheet for strengthening our specimen concrete. Let's go to create property of our composite. Create composite, mechanical elasticity, elastic. Let's type laminate, and let's add our property of our composite. The first Young modulus 170 megapascal, and third Young modulus 900 megapascal, 9000 megapascal, and also other parameters. We have all data or all parameters of our laminate property we will use. Click OK. Now we have material. Let's assign this sheet of composite with material. Create composite layer sheet C of RP. Let's add the counting of our layers. We have 5 layers, for example, conventional shell, continue, and now we have this table. Let's select the region of our composite sheet, edit region, select this part, click done, and material, edit material, select composite laminate, click OK. Thicknesses of each layer 0.25, for example, or 0.2, and angle of rotation. Let's edit angle of rotation. We can select one of these degrees in this list, or you can use your own angle depending on your material. For example, 0 in this rotation angle of each layer. Click OK. Now let's see our layers in, or our stacking of this sheet. Play stock plot. Click display. We have see our stacking and directions of each layer. Now let's go to assembly part, assembly module to assembly our sheet to our model. Select sheet, apply. Now we need to rotate in the right direction. Click rotate instance, select instance, click done, and select axis of rotation, the first point of axis and the second point of axis, 90 degree. Okay, and now let's translate in the right position. Click instance, select this point. Now select this, translate instance, select instance, click done, select starting point, ending point. Now we have this sheet and our specimen, our concrete specimen. Click OK. Now let's do some modification in our model. Let's see the thicknesses of our sheet. Assembly display option, render shield thicknesses, apply. Our sheet is with width of equal to 1 mm, and as we can see here, the width is in the inside of our specimen. Let's go to property module and edit our material composite and click offset of our thicknesses. Let's select top layer offset. That means that the thickness is starting from the top layer. Click OK, and now go to assembly module. Now let's go to edit property and select offset from bottom surface. Click OK, assembly. Now we have the right position and right offset. Now we need to go to our step. We can change any steps there. Let's go to interaction. For adding interaction between our sheet and our concrete specimen, let's select our sheet. We need to add create constraint. We need to add tie constraint between our sheet composite and our concrete specimen. With the interaction between these two parts is with tie. That means we have perfect connection between these two parts. Let's click continue. Surface. Let's select all. Let's make this option. Cell. Select this sheet. Now click done, and I need to. Now we have a wrong selection. Let's isolate our sheet first. Part instance, sheet, replace. We have just our sheet in our view. Let's create tie constraint. Continue. Select surface. Let's select, click done. Let's select the top surface of our sheet. that we that is in a contact direct with our specimen, the purple surface, not the other side. Click purple and surface. Let's invert display and now select the top surface, the bottom surface of our specimen, concrete specimen. Select this surface, click done, and now we have property of contact, die contact, constraint 1, two surfaces, and all parameters. Click OK. Now let's replace all and for show all parts in our model. Now we have a perfect contact and between these two parts, between our sheet composite and our concrete material, concrete specimen. We have die contact, edit. This is the position of our contact. Click OK. Now let's go to job and create a new job. CFRP repair. We continue. Okay, let's check first our model data check. Now we have the following part instances are not meshed. We can't submit. Let's go to mesh module and mesh our sheet composite size 10 millimeter. Okay, mesh. Yes. Now we have all parts are meshed correctly. Let's go to job data check. Completed. Check. Continue. Okay. Submitted. Running. We have aborted result, but don't worry about these results, these statements. Let's go to the result. Deformed shape. We have these damage traction result. Compression traction result damage. Compression damage. Now let's compare between two results. The first without composite repair and the second with composite repair. Let's create another viewport. Remove link between these two viewports and open ODP result in this. Compressive damage. Now we have different shape of damage between these two parts. Let's tensile damage and select also in this viewport tensile damage. Now this this is the result of our repairing, and Now I think we need to create and get the maximum reaction force into result. Let's find ODP output, continue, and select reaction force and displacement. We have these two values selected. Let's select which point we need to get the result. I think let's select manually, edit select this point, plot. Now we have this result. Let's plot the curve or create the force displacement curve. Combine displacement, reaction force, plot expression. I think this result of the first result without repair. Let's clear all. Clear all. No, let's go there. Clear all. Delete. Save these data as is. Click OK. Now let's create force displacement curve. Combine displacement, reaction force, plot expression. Let's reverse the curve. Minus, minus, plot expression. We have the curve of force displacement. Now let's go to the first result without composite repair or composite material patch. Let's create our force displacement curve, ODB file output, continue. We have select, plot. Now let's save this data as it's. I think we can find a problem with the name. Click OK. Now let's go to build our force displacement curve, continue. Combine. Now we have a problem in which reference and displacement you need to select. We need to select. Let's select these two. The first one, displacement. Now we have the curve of force displacement. The main idea between these two results is the maximum force equal to 0.2 power 6 times 10 power 6, and this is 0.12 or times 10 power 6. We have different results and we have better force and strength of our specimen. I hope you enjoy with this video tutorial. Don't forget to subscribe in my YouTube channel and make like for this video. See you soon.